Hey everyone, this is Unit 4 Quadratics. We're beginning a new unit, and so I want to start you out with just the basics of quadratics. You also have a guideline sheet for graphing quadratics. It's very similar to the one that we had for radicals and absolute value, and so anytime you need to refer back to that sheet, and that way it'll help you when you're graphing things by hand. I just want to go over some of the highlights to start us out in this unit, and that is the standard form and how to find different parts of a quadratic graph. So your standard form of a quadratic is y equals ax squared plus bx plus c, and in this case a, b, and c have to be integers. If we ever have fractions or decimals in for a, b, and c, then we need to multiply through by a number so that they'll all turn into integers. You guys don't really have to worry about that too much. Normally you have your standard form already in integers, but just in case you ever come across one that's got fractions, we'd have to multiply through so that it's in integer form in order for it to be in standard form. What's the graph of these going to look like? Well, they're going to look like parabolas. Parabolas are these U-shaped graphs. They could be face up or they can be face down. In Algebra 2, you only have to worry about face up and face down graphs. If you go on to higher level math, there's some parabolas that do go to the right and to the left. Those are called conic sections. We don't have to worry about those in Algebra 2, thankfully. So for us, we're just going to have a face-up graph or a face-down graph. The next thing is called an axis of symmetry. And an axis of symmetry is really, it's an invisible line. You won't see it, and it bisects the parabola. So the word bisects kind of comes from your geometry class, and it means to cut something in half. Also, you've probably seen the word symmetry before from geometry, and sometimes in geometry they ask you how many lines of symmetry a shape has or a letter, and I drew a capital letter A over here, and if I were to ask you how many lines of symmetry that A has, you could see that we would just be able to draw one line of symmetry right down the middle of that A. A line of symmetry cuts the A in half, so that this half of the letter maps onto the other half. So an axis of symmetry is still a line. It's a special line that cuts your parabola in half. So we could go right down through the middle of this parabola, and this half would map onto the other half. And same with this one. We'd go right down through the middle, and the two halves would match onto each other. I draw it as a dotted line because it is invisible. It's not something that when you graph in your calculator will show up. So it's just something to help us as a guideline for when we graph them by hand. Okay, the next part is a vertex. The vertex is the middle of the parabola. It's the very middle. So it's either going to be this point right here if it's a face-up parabola, and it's a point, x comma y, or it's going to be this point up here at the top. And that's also going to be the middle of that parabola. While I'm talking about a vertex, I want to talk about what kinds of vertexes we can have. So I'm going to jump down here. I'm going to skip over domain and range just for a minute and talk about min and max values. Your vertex has a special name based on where it is on the parabola. So if your vertex is down at the bottom of a parabola, like down at the low point, it's going to be called a minimum, or a min for short. If your vertex is up at the top of your parabola, then it's going to be called a maximum, or a max. So these words for min and max are just special names for the vertex, depending on where it is on the parabola. Next is domain and range. So your domain is going to be from left to right, and for all your parabolas, the domain is going to be from negative infinity to positive infinity. Your range is going to depend on where that vertex is. If you have a face-up parabola, your range is going to go from the y-coordinate of the vertex to infinity. And then if you have a face-down graph, your range is going to go from negative infinity up to that y coordinate. So these are just the basics. You'll get a lot better at this the more we practice it. And if you need to pause the video at any time to catch up, feel free to do that and then write everything down. Start the video when you're ready. Okay, we're going to go down to the first couple of examples. In these examples, we're going to practice how to find the axis of symmetry and how to find the vertex for each equation. We're going to do this by hand, so we're going to use the formulas that were given to you on that first graphing sheet for quadratics. So on that sheet, you have axis of symmetry. I'm going to abbreviate it as AOS. That equals this formula, x equals negative b over 2a. So this formula has a b and an a in it. So that means we've got to figure out what b and a are in order to do this formula. Well, b and a and c all come from your equation. Remember up here for standard form, a is the number in front of the x squared, b is the number in front of the x, and c is the constant. So when I find my axis of symmetry, I'm going to use those numbers that are in front of x squared and the number that's in front of the x. So this is going to become negative, because there's a negative right here, and then whatever b is. Well, b happens to be a negative 4. So it's a negative 4 over 2 times a is the number in front of x squared, so 2 times negative 3. So a negative 4 turns positive, and then 2 times negative 3 is negative 6. And then we could reduce that further to be negative 2/3. So your axis of symmetry is going to be x equals negative 2/3. So we have one answer already. Now, to get your vertex from that, you're going to plug negative 2/3 in everywhere that you see an x in your equation. And so I'm going to erase this so that it doesn't look quite so bad. Okay, so we're going to plug in that negative 2/3. It's going to go right here, and it's going to go right here. And it's okay if you use your calculator to do this. Okay, you should all have a graphing calculator in class assigned to you, and so go ahead, use your calculator, or if you're at home and you don't have your calculator, grab your phone or grab a calculator that you might have laying around at home. So negative 3 times, now I'm going to put negative 2/3 in everywhere I see an x. So I'm going to make it look nice with the alpha y equals negative 2/3, close the parentheses. Then we need to square it, and then minus 4 times negative 2/3, close the parentheses, and then plus 6, just like the equation gives us. I'm going to hit enter, and there you go. Now, if you got a decimal answer, then that's okay if you have a decimal answer. If you want to change it to a fraction, you go to math, this math button right here on your calculator. We used it a lot in the radicals section. And then choice number 1 is to fractions, changes it to fraction, hit enter, and then it'll change it to a nice, I already had a fraction, but if you have a decimal, it will change it to a fraction for you. So if I put those two answers together, it's going to be vertex equals, it's a point, the x coordinate is the x that you found for your axis of symmetry. The y coordinate is the answer that we just got in our calculator, so 22/3. So now we've found our axis of symmetry and we found our vertex for that. Okay, so let's look big picture at this. What do these two answers mean? Remember, this is a line that cuts your graph right down through the middle. And this is the middle of your graph. It's that point. It's either going to be a max or a min. So if we use our graphing calculator to get a graph of this, we can put it into the y equals negative 3x squared minus 4x plus 6 and hit graph. And there's your picture. I'm on a standard window, so you might want to do zoom number 6 to make sure that you have a nice standard window. Depending on who used your calculator before you, they may have changed the window. So here's your parabola. And so if you were to hit trace on your calculator, trace is right next to graph, and arrow over all the way up at the top, you would see that we are, well, it's kind of hard to get exactly on there, but we're pretty close. You're at an x value of negative 0.6. Negative 2/3 is close to negative 0.6. It's actually negative 0.6 repeating. So that is your axis of symmetry, because if we imagined a line going right down through this parabola, it would be going through x equals negative 0.6 repeating. And then your vertex is negative 0.6 comma 7.32. Now if you divide out 22 over 3 in your calculator, there's 7.33, so we're pretty close. 7.33, 7.32. There is your vertex. So there's ways that you can check your answers to make sure that you're on the right track and you didn't make an arithmetic error. But that's what that means when you're finding those answers. Let's do the second example. So I'm going to kind of separate what I had here, and then let's also start by writing out A, B, and C. So A is 2, B is 10, and C is 7. So we're going to find the axis of symmetry first, which is x equals negative b over 2a. Then we're going to find the vertex. And we're going to do that after we find this. We're going to plug this in wherever we see an x in our equation. So to find our axis of symmetry, we're going to do negative and then find our b value, which is 10, over 2 times 2, like so. And so that's going to be negative 10 over 4, which is the same as negative 5 over 2. So your axis of symmetry is going to be x equals negative 5 over 2. There's your axis of symmetry answer. That part's done. Now, to find the vertex, we're going to plug in that negative 5 halves everywhere that we see an x in our equation. So I'm going to come over here. This is our equation, 2x squared plus 10x plus 7. So 2 parentheses, I'm going to use the fraction, negative 5 over 2, and we're going to square it, plus 10 times negative 5 over 2, and then plus 7. And we're going to hit enter. So our answer is negative 11 over 2. So that's your y coordinate of your vertex. You're going to write your vertex as a point. The x coordinate is the negative 5 halves that we just plugged in, and the y coordinate is the negative 11 halves. So your vertex will be at negative 5 halves, negative 11 halves. So negative 5 halves is like negative 2.5, and negative 11 halves is negative 5.5. If you're trying to think, like, imagine it is a decimal. Let's look at the graph for this and see how this all plays apart together. So 2x squared plus 10x plus 7, and hit graph. Okay, there's your picture. So if we hit trace, which is right next to graph, and then arrow over to where we think the middle of the parabola would be, try to find it the best that we can. Does everybody see that it's about, and this is an estimate, definitely, it's about negative 2.5, negative 2.6 if we round up, and then over here it's negative 5.49, or if we rounded, negative 5.5. So we can see that we did a good job on finding our axis of symmetry and our vertex by hand, and we can also see where these answers are coming in on the graph. This is the very middle of the parabola, and then this -5/2, if you could imagine a vertical line going right equals, and so
it would be x equals -5/2. Okay? Okay, so let's go down and do another example. And let's actually do some graphs with this. We'll do a little table of x and y's and plot some graphs. So this equation is f of x equals x squared. So the a is 1. The b, it's like we don't have any b or c. So that's going to be 0x plus 0. Okay, if there's nothing there, it's really 0, right? So a is 1, b is 0, and c is 0. To find your axis of symmetry, you're going to do x equals -b over 2a. So this is going to be -0 over 2 times 1. Well, even if it's -0, it's still 0. And 0 divided by anything is still 0. So your axis of symmetry is x equals 0. And I'm actually going to graph that on my axes so that you can see how this all works together. So x equals 0 would be basically the y-axis. And I'm kind of doing mine a little bit next to it so it'll stand out. Okay, so that's your axis of symmetry. X equals 0. Remember, that's an invisible line. It wouldn't show up on your calculator if you graphed it. Now, to find the vertex, you're going to take this 0 and you're going to plug it in everywhere you see an x. Well, 0 squared is 0. So your vertex will be 0, 0. That's going to be right there at the origin. So I put a point right there. Now, we don't know any other information, but we can do a table of x and y values to help us get a graph. And we'll just do a few points on the right of the vertex and a few points on the left, maybe 2 on each side. So let's do maybe -2, and we'll do +2, and we'll do -3 and +3. Okay, just a few points. So if I put -2 into my x, -2 squared is going to be 4. So at -2, you're going to go up 4. 1, 2, 3, 4. We're right here. Okay. And then if I put +2 in to my x, this will be 2 squared. That also equals 4. So over 2 and up 4 right here. So -3, if I put -3 in for my x, remember the negative gets squared also. So -3 squared is 9. So that's going to be up here. And then +3 is also going to be 9. So that's going to come right up here. Now remember, we know that these are like a U shape. It's a curve. It's not pointy. It's not like a V shape, like absolute value. So you're going to try to make a curve the best that you can. Oh, I missed that point a little bit. Do the best you can. And then make a curve on this side. And that's your graph of your parabola. All right, let's go on to this example right here, the last example. So a is the number in front of x squared, which is a 1. B is the number in front of x, which is 2. And c is 3. So we're going to find the axis of symmetry, which is x equals -b over 2a. X equals, so -b would be -2 over 2 times 1. Well, -2 divided by 2 is equal to -1. So your axis of symmetry is x equals -1. So let's go ahead and graph that. -1 would be to the left 1, and it would be a dashed vertical line. We're making it dashed because we know that it is invisible. So now to find the vertex, you're going to put -1 in everywhere that you see an X. So we can use our graphing calculator to help us out with that. So it'll be -1. Notice I am putting parentheses around the -1. That's important. Okay. And then plus 2 times -1, and then plus 3. Oops. Back out of that. And then hit enter. And we get 2. So if we put these together, your vertex will be -1, comma 2. So you go over 1 and up 2. That's your vertex. Now we'll do a table of X's and Y's to help us out with this. So we'll do a couple of points on the right hand side of the vertex and a couple of points on the left hand side. So let's do, how about 0 and 1, and then we can also do, how about -2 and -3. Okay, so to find the y coordinate, you're going to put a 0 in everywhere that you see an X. So this would be 0 squared plus 2 times 0 plus 3. That's going to be equal to 3. So you're going to go 0 and then up 3. 1, 2, 3. Put a point. If you put a 1 in, it'll be 1 squared plus 2 times 1 plus 3. So this is 1 plus 2 is 3. 3 plus 3 is 6. So over 1, up 6. 1, 2, 3, 4, 5, 6. So we're going to put a point right there. To find -2, we're going to do -2 squared plus 2 times -2 plus 3. And if you need some help with this, put it into your calculator. It's okay. That's going to come out to be 3. So this is over 2 and up 3. Plus another reason that I know that this is going to be 3 is that all of these points need to be symmetrical on both sides. This line of symmetry means that this half of the parabola looks just like this half of the parabola. So that's another reason that I knew that that had to be 3. And then if you do -3, put that in everywhere you see an X. So let's see. That one's going to be 6. We're going to go up 6. Okay? So these are all by hand. So do the best that you can. Make a nice U shape. Definitely mine are not perfect either, but we do the best that we can. There we go. And then this is going to go up like that. And then there's your second parabola. Your axis of symmetry is at x equals -1, and your vertex is -1, 2. So after seeing these, try the graphs on the back and show me. Hope that helps. Thanks.